Hey there and welcome. Today we are going to talk about how to define, identify, calculate, and estimate square roots. That's a lot, so let's get going. Alright, so in our last lesson we discussed how to calculate squares. Today we're going to go in the opposite direction and we call this an inverse operation. An inverse operation undoes the original operation. So for example, if we are adding, the inverse of that, the opposite, is going to be to subtract. Vice versa, subtracting's inverse is going to be to add. Multiplying's inverse is dividing. Dividing's inverse is multiplying. The inverse of square is square root, and the inverse of square root is square. So let's take a look at this square that we have here. Let's break down a square root. So we have this n, this funny looking symbol, and then this x. And what does all of it mean? Well, first we have this funny looking symbol, which is called a radical. And a radical is just taking a root. If it's a square root, a cube root, a 10th root, whatever it is, it's that symbol that lets us know that we're taking a root of some sort. Then we have the radicand, which is the number or the variable inside the radical. It's the value that we're taking the root of. And then we have this n that's off to the side here. And that's called an index. And it tells us what type of root we're taking. It tells us if it's a square root, if it's a cubed root, if it's a 10th root. It tells us what that root index is. So let's look at this example here. So if we have the square root of 9, we're going to figure out what that index is, which in this case is invisible because you can see there's no number right here. And when there's no number, it actually is automatically a 2. It's automatically a square root. It's the most common one that we tend to use, so we don't really write it. The radicand, the number underneath the radical, is 9. So we have to figure out what number multiplied by itself is 9. Well, based on the list of perfect squares that we had in the previous lesson, we know that the square root of 9 is 3 because 3 times 3 gives us 9. We have to be super careful because negative 3 times negative 3 is also positive 9. So the square root of 9 really has two answers. It has a positive 3 answer and it has a negative 3 answer. And the way that we write that is just plus or minus 3. So let's look at another example here. This time we have the square root of 256. Again, our index is invisible, so it's 2 automatically. It's a square root. And our radicand is 256. So we have to figure out what number multiplied by itself is 256. Well, 256 is made up of 16 times 16, but it's also made up of negative 16 times negative 16. So again, square roots will always have two answers, the positive and the negative. So we're going to say that the square root of 256 is plus or minus 16. We can also take the square root of fractions. So if I have the square root of 4 over 25, I can take that fraction and that square root and break it into two separate square roots in the fraction. So I can have the square root of 4 over the square root of 25, and then take the square root of 4, which is plus or minus 2, and then the square root of 25, which is plus or minus 5. And so the square root of 4/25 is plus or minus 2/5. But what about negatives? What if we have the square root of negative 25, we have to figure out what number multiplied by itself is negative 25. Well, 5 times 5 is 25, and negative 5 times negative 5 is also positive 25. So these are both positive numbers. At this moment, we don't know how to solve this because the only way that we can get a negative 25 is if we have a negative number times a positive number, and that's not the definition of a square root. It has to be the exact same number. And a positive number and a negative number are not the same. So right now, we don't know how to solve this. Our solution for this class would be no real solution. I'm not saying that there's no solution because there is one, but for the purpose of this class, we don't know it yet. So right now, if we have the square root of a negative number, our answer is just going to be no real solution. You will learn how to get to that solution when you hit Algebra 2. So sometimes, and most likely, the number that you're going to have is not going to be a perfect square. So we have to estimate. We have to figure out how to do that. Well, here's how. If we have the square root of 15, I'm going to look through my list of perfect squares and I'm looking at the numbers in red. And I need to find where 15 is. But as it turns out, 15 is not in this list because there is not a whole number multiplied by itself that's going to give me 15. It's not a perfect square. So instead, what we need to do is we need to find those two perfect squares that it falls between. 15 falls between 9 and 16. Those are the perfect squares that it falls between. So then we're going to make a number line. So I have my 9 up top, my 16 up top. Those are my two perfect squares. But then I have the two bases that actually made them on the bottom. It's going to help me later when I have to figure out what that decimal point needs to be. So now I need to identify where 15 would go on that top portion. Is it going to be closer to 9? Is it going to be closer to 16? Is it going to be closer to the middle? I need to figure that out. And I'm going to say that it goes about right there. It may not be exact, it may not be perfect, but it's definitely much closer to 16 than it is to 9. So what is that number that we had to square to get there? Well, it's called estimating, not perfection. Right? We're going to make an educated guess about where it would be. And I'm going to say that that's about 3.8. I'm not saying it's exactly at 3.8 because in reality, it's probably a decimal that goes on much farther anyway, but it's about right there. Now, if you say 3.9, that's totally fine. I understand why you would get 3.9 because it's 15 is one number away from 16. 3.9 is one number away from 4.0. I get this. If you put about 3.9, that would be totally fine. But be super, super careful and don't forget your plus or minus. Because again, the negative number also multiplies to give us that positive answer. So we would say that the square root of 15 is about plus or minus 3.8, about plus or minus 3.9. I would accept either one of those answers. All right, so let's review what we learned. We can define inverse operations and square roots. We can identify the radicand and the index. And we can calculate and estimate square roots. That was a lot. And until next time, I'll see you later. Love you, bye.